All right, so this lesson is kind of just like building vocabulary, and you're actually going to be learning a new way to measure angles, and we're just going to be learning how to go from degrees to this new thing that we're going to call radians. So today's notes is about radian measure. And traditionally, when we're talking about trigonometry, our angles are going to be measured in radians. So we explained what radians were in class. And so now what we're going to do is we're going to use that information, and we're just going to convert each of these angles that are measured in degrees into radians. And then after that, we'll just use our trig functions that we know how to use. But instead of giving you angles in degrees, I'm going to start giving you angles in radians. So let's talk about, real quickly, what we learned about radian measure in the first place, and just make some notes over here. So this is what we talked about in class. The radius of a given circle. So here's a circle. This is the unit circle, so we actually know that r is 1. But this is true of any circle. If you have a radius of this circle and you lay it down along the circumference of that circle, we said that it's going to fit around that circle 6.28 times. So that would be like me taking this r and laying it down once, and then I'd need another one, 3, 4, 5, 6, and then a little extra. That's true of any circle. It will always be 6.28 times the radius of the circle, roughly. And actually, this is where we start to realize that this is where pi comes from, because how many times does this thing fit around the circle, or half of just the circle, right? So there's 1, there's 2, there's 3, and then there's a little extra here, which we said is 0.14. 0.14, and it goes on. There are other decimals, right? And we get that from, or we can see that that's related to pi, because that's exactly what pi is. Pi is just you measuring how many times the radius goes around half of the circle that it's come from, right? So pi is 3.14159. It goes on forever and ever and ever. That's pi, and that's because that's exactly the number of radii that you would have to lay down along this circle to get halfway around the circle. And that's where radians come from. So with that in mind, then from now on, instead of saying 180 degrees takes us from here to here, let's say that pi radians takes us from here to here, all right? So if that's pi, and let me just label that, I'll just put, here's an arc indicating an angle, and the measure of that angle is pi. Pretty straightforward, right? So with that in mind, let's move on and talk about 360 degrees. Well, if pi takes us 180 degrees, how do we take this 180 and turn it into a 360? Well, what we would have to do is we would have to multiply both sides by 2, and whatever I do to one side, I have to do to the other side. So if I have 360 degrees, that's the same as having 2 pi radians, right? That makes sense. That's kind of like the same thing we were doing when we were talking about these special right triangles. And we could just keep doing this same exact thing. If pi is 180, and I want to turn a 180 into a 90, what do I need to do? I need to divide it by 2. And so I'm going to have to do that to both sides. So that means that 90 degrees is the same as pi over 2 radians. The other way that you can do this is you can set it up like a ratio, right? And we can set two fractions equal to each other. We can say that we know that pi is to 180 as some measure of radians is to 270. This is the same process, same thing. It's just another way to think about it, another way to look at it. If I have these two things equal to each other, now what I have to do is I have to get x by itself. So how do I get rid of this divided by 270? Well, multiply both sides by 270. Got to do the same thing over here. And now I have that x equals 270 pi over 180. And I have to work on how to reduce that. And what I'm going to find is that 270 over 180 is the same as 3 halves, which is to say that 270 degrees is the same as 3 pi over 2. So we're just doing this. We're just taking each degree measure, turning it into radians. And we've got a couple different ways to do it. So you could do it either way you want to do it. 30 degrees. Let's do it the second way now. So we know that pi is to 180 as some measure of radians is to 30. How do we get that x by itself? Times 30 times 30. And now we've got 30 pi over 180 equals x. We have to reduce this. Can cancel those. And now I have 3 over 18, which reduces to 1 pi over 6. So 30 degrees is pi over 6. That's going to be one we use a lot, right? Because we have a lot of triangles that are 30, 60, 90 triangles. So instead of having 30, 60, 90 triangles now, we're going to have pi over 6, some measure, whatever 60 comes out to be, and pi over 2 triangles, because our degrees are now going to be measured in radians, or our angles are going to be measured in radians rather than in degrees. 45 degrees. Let's do it the other way. I don't know which way works best for you, but I know that pi equals 180, and now I have to turn that 180 into a 45. So if I'm going to do that, I'm just going to divide it by 4, which is going to have to be the same thing that I do to this side. 180 divided by 4 is 45, and that turns this side into pi over 4 radians. So now I know that if I have a 45, 45, 90 triangle that looks like this, the measures of these angles could, instead of 45, be pi over 4, pi over 4, and this one is pi over 2. Right? And my side lengths are still 1, 1, radical 2, but now I'm just measuring the angles differently than I was in the past. Come over here to 60 degrees. Let's do it the second way. So we have pi, and we know that that is to 180, as some measure of radian angle measure is equal to 60. We don't know what the radian measure is, but what we're doing here is we're just putting our radians on the top in the numerator and our degrees on the bottom. Radians is to degrees as radians is to degrees. Got to find a way to get rid of that 60. So what I'm going to do is multiply both sides by 60 times 60. And now I'm going to have x equals 60 pi over 180. If I reduce that fraction, I get 6 over 18, which is the same as 1 pi over 3. And so now I've figured out the angles of my other special right triangle. If I have what used to be a 30, 60, 90, where this side is 1, this is 2, this is radical 3, this is 90 degrees, which now we know is the same as pi over 2 radians. This used to be my 60 degree angle over here, and instead of calling it 60 degrees, I can call it pi over 3 radians, and my 30 degree angle I can just call pi over 6 radians. Still the same exact triangle, just a new name for the measures of these angles. So if I want to calculate cotangent of pi over 3, and I'm not going to go through the whole calculation right now because we've done this in the past, what we've got to do is figure out what is pi over 3. It's easiest to calculate these if we put these into our degree measure. Okay, so I have radians here. I want to know, how would I write pi over 3 in degrees? And I see it on this page, but if I hadn't just done this, then what I would do is just set it up the same way I've done these other ones, right? I know that pi is to 180, just as pi over 3 is to something. Don't know what that something is yet. So now I'm solving this is what I'm doing. I want to get rid of that denominator, so let's just multiply both sides by x. All right, so now what I've got is pi times x over 180 equals pi over 3. I want to get that x alone eventually, right? So the next thing I'll do is multiply both sides by 180. Okay, so now I have pi times x equals 180 pi over 3. I can reduce that side, so now I have pi times x equals 60 pi. And now what I've got to do is get x alone, so I'm just going to divide both sides by pi. X equals 60. So now from that point I would just have to calculate cotangent of 60 degrees, which is something that we're very familiar with doing. All right? So tomorrow in class we're going to practice, but instead of using degrees, we'll be using radians.